Chapter 8, Question 1. Molten AlCl3 is electrolyzed with a current of 0.5 ampere to produce 27 gram of aluminium. How many gram equivalents of aluminium were produced? So answer to the first part will be equivalents of aluminium equal to weight of aluminium, that is 27, divided by equivalent weight of aluminium, that is 9, and this is equal to 3. Therefore, number of gram equivalents of aluminium is equal to 3. Second part, how many gram atoms of aluminium were produced? Answer to the second part is gram atoms of aluminium is equal to weight of aluminium, that is 27, divided by atomic weight of aluminium, which is also 27, and this is equal to 1. Therefore, gram atoms of aluminium is 1. Third part, how many atoms of aluminium were produced? For this, first of all, we will find the number of moles of aluminium, which is equal to weight of aluminium, that is 27, divided by atomic weight of aluminium, which is also 27, and this is equal to 1. So 1 mole of aluminium is produced. Now 1 mole of atoms contains Avogadro number of atoms. Therefore, number of atoms of aluminium is equal to Avogadro number of atoms, which is equal to 6.022 into 10 to the power 23 atoms. Fourth part, how many electrons were required? Now Al3 plus ion, this is the fourth part. Al3 plus ion takes up 3 electrons to form aluminium, or we can say 1 mole of aluminium ions accepts 3 moles of electrons to form aluminium. Now 1 mole of electron means Avogadro number of electrons. Therefore, 3 moles of electrons will be equal to 3 into Avogadro number of electrons. Or we can say that number of electrons is equal to 3 into Avogadro number of electrons, which is 6.022 into 10 to the power 23 electrons. Therefore, number of electrons required is equal to 3 into 6.022 into 10 to the power 23 electrons. Fifth part of the question is, what is the number of Faradays of electricity consumed? Now 1 Faraday of electricity liberates 1 equivalent of substance. Now equivalents of aluminium is equal to 3. Therefore, number of Faradays of electricity is equal to 3 Faradays. Sixth part of the question, how long did the electrolysis take place? The number of Faradays of electricity consumed in this electrolysis is 3 Faradays, and 1 Faraday is equal to 96500 coulombs. Therefore, 3 Faradays will be equal to 3 into 96500 coulombs. And as we know, Q is equal to IT, where Q is the charge, I is the current, T is the time. From this, T will be equal to Q divided by I, and this is equal to 3 into 96500 coulombs divided by the current, which is 0.5 amperes. This will give the time in seconds, and dividing this by 3600 will give the time, which is equal to 160 hours and 50 minutes. This is the sixth part of the question. Now, the seventh part of the question, how many liters of chlorine at NTP were produced? Now we know that in this electrolysis, 3 Faradays of electricity was consumed. 1 Faraday of electricity liberates 1 equivalent of substance. Therefore, 3 Faradays of electricity will liberate 3 equivalents of substance. Therefore, equivalents of chlorine liberated is 3 equivalents. Therefore, equivalents of chlorine liberated is equal to 3 equivalents. Now, 1 equivalent of chlorine occupies volume equals to 11.2 liters. Therefore, 3 equivalents of chlorine will occupy the volume equals to 3 into 11.2, which is equal to 33.6 liters. Therefore, volume of chlorine produced at NTP is 33.6 liters. Question 2. In the electrolysis of an aqueous chromium sulfate solution using a current of 2 ampere, the mass of cathode is increased by 8 gram. How long was the electrolysis conducted? Now, during electrolysis, this chromium sulfate will break into chromium ions and sulfate ions. Chromium ions will move to cathode and they will accept 3 electrons and will be deposited on the cathode. So we can write Cr3 plus 3 electrons forming chromium. So these chromium atoms will be deposited on the cathode, because of which there will be increase in the weight of cathode. As can be seen from this equation, the change in oxidation number of chromium is 3. Therefore, equivalent weight of chromium will be atomic weight of chromium divided by 3, which is equal to 52 divided by 3. This is the equivalent weight of chromium. Now, increase in the weight of cathode will be equal to the weight of chromium, which is equal to 8 grams. Therefore, weight of chromium is equal to 8 gram. Equivalents of chromium will be equal to weight of chromium, that is 8 gram, divided by equivalent weight of chromium, which is 52 by 3. Now we know that one equivalent of matter is liberated by 1 Faraday of electricity. Therefore, Faradays of electricity consumed in this electrolysis will be equal to equivalents of chromium, that is 8 by 52 into 3 Faradays. Therefore, the charge in coulombs will be 1 Faraday is equal to 96500 coulombs. Therefore, 8 by 52 into 3 Faradays will be equal to 8 by 52 into 3 into 96500 coulombs. Now applying the formula Q is equal to IT, we know the value of Q. The value of I is given in the question as 2 amperes. From this, the value of time will be equal to Q divided by I. T is equal to Q divided by I, and this will be equal to 8 divided by 52 into 3 into 96500 divided by 2, and dividing this by 3600 will give the time in hours, and this is equal to 6.185 hours. Therefore, this electrolysis will be conducted for 6.185 hours. Question 3. A spoon used as a cathode is dipped in AgNO3 solution and a current of 0.2 ampere is passed for 1 hour. Calculate how much silver plating has occurred, how many electrons were involved in the process, what amount of copper would have been plated under similar conditions. Now, how much silver plating has occurred means we have to find out the weight of silver. Now, equivalence of silver is equal to number of Faradays of electricity passed, and number of Faradays of electricity passed will be equal to number of Faradays of electricity will be equal to Q divided by 96500 coulombs, where Q is the charge in coulombs, which is equal to I into T, divided by charge, which is equal to 1 Faraday, that is equal to 96500 coulombs. Now this Number of Faradays of electricity is also equal to equivalence of silver. Therefore, equivalence of silver is equal to, the value of I is 0.2 amperes into T. The value of T is 1 hour or 3600 seconds divided by 96500. This gives the equivalence of silver. From this, weight of silver is equal to equivalence of silver, that is 0.2 into 3600 divided by 96500 into equivalent weight of silver. The equivalent weight of silver is equal to 108. Solving this, the weight of silver is equal to 0.805 gram. Now the second part of the question, how many electrons were involved in the process? Now 1 mole of silver ion will accept 1 mole of electrons to form 1 mole of silver. Therefore, moles of silver is equal to moles of electron. Therefore, moles of electron is equal to moles of silver, which is equal to 0.805, that is weight of silver, divided by atomic weight of silver, that is 108. Therefore, moles of electron is equal to 0.805 divided by 108 moles. Now 1 mole of electrons is equal to Avogadro number of electrons, or 6.022 into 10 to the power 23 electrons. Therefore, number of electrons will be equal to 0.805 divided by 108 into 6.022 into 10 to the power 23, and this is equal to 4.5 into 10 to the power 21 electrons. Now the third part of the question, what amount of copper would have been plated under similar conditions? Now equivalence of copper will also be equal to number of Faradays of electricity passed. Therefore, equivalence of copper is equal to number of Faradays of electricity passed, which is equal to 0.2 into 3600 divided by 96500, and from this, weight of copper will be equal to equivalence of copper, that is 0.2 into 3600 divided by 96500 into equivalent weight of copper. Equivalent weight of copper is 63.5 divided by 2. Solving this, weight of copper is equal to 0.237 grams. Question 4. A steady current passing through a solution of silver nitrate solution deposits 0.50 gram of silver in 1 hour. Calculate the number of coulombs. What volume of hydrogen at 27 degrees centigrade and 750 millimeter pressure would the same current liberate in 1 hour? Weight of silver is given as 0.50 gram. Time is given as 1 hour, which is also equal to 3600 seconds. Now we know that W is equal to ZIT and I into T is equal to the charge. Therefore, we can write W is equal to Z into Q. Therefore, Q will be equal to W divided by Z. W is given as 0.50 gram. Z is equal to equivalent weight. In this case, it will be equivalent weight of silver. The equivalent weight of silver, that is 108, divided by 96500 coulombs. Solving this, the charge is equal to 446.7 coulombs. Now, equivalence of hydrogen liberated will be equal to the Faradays of electricity passed, and equivalence of hydrogen in terms of volume can be written as, let the volume of hydrogen liberated be V1. Therefore, equivalence of hydrogen will be equal to volume of hydrogen liberated, that is V1, divided by equivalent volume of hydrogen, that is 11.2 liters, and this is equal to Faradays of electricity passed. Now Faradays of electricity passed will be equal to the charge in coulombs, that is 446.7, divided by the charge carried by 1 Faraday of electricity, that is 96500 coulombs. Solving this, the volume of hydrogen is equal to 0.518 liters. Now this is the volume of hydrogen liberated under normal temperature and pressure conditions. Therefore, applying the formula P1V1 by T1 is equal to P2V2 by T2, where P1 is 1 atmosphere, T1 is 273 Kelvin, V1 is given as 0.518 liters, P2 is 750 by 760 atmospheres, V2 we have to find out, T2 is given as 300 Kelvin. Solving this equation, the value for V2 is equal to 0.0577 liters, or it is also equal to 57.7 milliliters. Question 5. At the Nangal fertilizer plant in Punjab, hydrogen is produced by the electrolysis of water. The hydrogen is used for the production of ammonia and nitric acid by oxidation of ammonia. If the average production of ammonium nitrate is 5000 kg per day, estimate the daily consumption of electricity per day. The average production of ammonium nitrate is 5000 kg per day, or it can also be written as 5000 into 10 to the power 3 grams per day. The equation for the reaction will be ammonia plus HNO3 forming NH4NO3. Now equivalence of ammonia is equal to equivalence of HNO3, which is equal to equivalence of NH4NO3, and this is equal to 5000 into 10 to the power 3, that is weight of ammonium nitrate, divided by 80. 80 is the equivalent weight of ammonium nitrate, and this is equal to 6.25 into 10 to the power 4. Now valency factor of ammonia is 1, valency factor of nitric acid is 1, and valency factor of ammonium nitrate is 1. And we know that number of moles is equal to number of equivalents into valency factor. Now since the number of equivalents is same, valency factor is same, therefore number of moles will also be same. Therefore we can write number of moles of ammonia, here n denotes number of moles, is equal to number of moles of HNO3, which is equal to number of moles of NH4NO3, and this is equal to, let it be n, which is equal to 6.25 into 10 to the power 4. Now applying principle of atom conservation to hydrogen atoms, moles of hydrogen atoms in ammonia is equal to 3 into moles of ammonia, that is n, and applying principle of atom conservation to hydrogen atoms in nitric acid, the moles of hydrogen atoms in nitric acid will be 1 into moles of nitric acid, that is n. Adding the moles of hydrogen atoms in ammonia and moles of hydrogen atoms in nitric acid, adding these two, we get the total number of moles of hydrogen atoms, which is equal to 4 into n. Now the value of n is 6.25 into 10 to the power 4. Therefore, moles of hydrogen atoms is equal to 4 into 6.25 into 10 to the power 4, and this is equal to 25 into 10 to the power 4. Now 1 mole of H plus ions accept 1 mole of electrons to form 1 mole of hydrogen atoms, or we can say moles of hydrogen atom is equal to moles of electron. Moles of electrons is equal to 25 into 10 to the power 4 moles. Now charge carried by 1 mole of electrons is 96500 coulombs. Therefore, the total charge carried by 25 into 10 to the power 4 moles of electron will be, that is Q will be equal to 25 into 10 to the power 4 into 96500 coulombs. The time is given as 1 day, which is equal to 24 hours, and this is equal to 24 into 3600 seconds. Current will be equal to Q by T, which is equal to 25 into 10 to the power 4 into 96500 coulombs divided by 24 into 3600, and this is equal to 2.8 into 10 to the power 5 ampere per day. Question 6. In an electrolysis experiment, current was passed for 5 hours through two cells connected in series. The first cell contains a solution of gold and second contains copper sulfate solution. 9.85 gram of gold was deposited in the first cell. If the oxidation number of gold is +3, find the amount of copper deposited on the cathode of the second cell. Also calculate the magnitude of the current in ampere. 1 Faraday is equal to 96500 coulomb. Atomic weight of gold is 197. Now in this question, atomic weight of zinc is given here as 65.4, but in the question we will need atomic weight of copper. So atomic weight of copper is equal to 63.5. Now applying the formula, equivalent weight of gold divided by equivalent weight of copper is equal to weight of gold deposited divided by weight of copper deposited. Equivalent weight of gold will be atomic weight of gold, that is 197 divided by 3. Equivalent weight of copper will be atomic weight of copper, that is 63.5 divided by 2. Weight of gold deposited is given in the question as 9.85 gram. From this we get the weight of copper equals to 4.76 gram. Now second part of the question is to calculate the magnitude of current in ampere. Now applying the formula, W is equal to ZIT, where W is the weight of copper deposited, that is 4.76 gram. Z is equal to the equivalent weight of copper, that is 63.5 divided by 2 divided by 96500 coulombs. I we have to calculate. T is given in the question as 5 hours or 5 into 3600 seconds. Now solving this equation, the value for I will be equal to 0.8037 ampere. Z is electrochemical equivalent, whose value is equivalent weight, which in this case is equivalent weight of copper divided by 96500 coulombs. Question 7. A constant current flowed for 2 hours through a potassium iodide solution, oxidizing the iodide ion to iodine. The equation is 2 moles of iodide ion change into 1 mole of iodine and give 2 moles of electron. At the end of the experiment, the iodine was titrated with 21.75 milliliter of 0.0831 m sodium thiosulfate solution. The equation is given as 1 mole of iodine plus 2 moles of thiosulfate ion gives 2 moles of iodide ion plus 1 mole of S4O6 2 minus ion. What was the average rate of current flow in amperes? Now both these equations are balanced equations, and from this balanced equations it can be seen that moles of iodide ion, moles of electron and moles of thiosulfate ion are equal. Therefore, it can be written as moles of electrons is equal to moles of thiosulfate ion, that is S2O3 2 minus ions, that is S2O3 2 minus, and this is equal to. Now how to get moles of thiosulfate ion? To get the moles of thiosulfate ions, multiply the molarity of sodium thiosulfate solution, that is 0.0831 m, by volume of the sodium thiosulfate solution, which is given as 21.75 milliliter, or in liters it will be 21.75 divided by 1000 liters. Therefore, moles of thiosulfate ion is equal to 0.0831 into 21.75 divided by 1000. Now, value of current in amperes is equal to total charge divided by time. Now, how to obtain the charge? We know that charge carried by 1 mole of electrons is equal to 96500 coulombs. Therefore, to obtain the total charge, just multiply the moles of electron by 96500 coulombs and it will give the total charge in coulombs, and dividing it by time will give the current in amperes. Therefore, the current is equal to 0.0831 into 21.75 divided by 1000 into 96500 divided by time in seconds. The time given in question is 2 hours. Therefore, time in seconds will be 2 into 3600 seconds. Solving this, the value for current will be equal to 0.242 ampere. Question 8. During the electrolysis of chromium chloride, chlorine gas is evolved at the anode and chromium is deposited at the cathode. How many grams of chromium and how many liters of chlorine at NTP are produced when a current of 6 amperes is passed for 1 hour? Current is given, time is given as 1 hour. Therefore, the total charge will be equal to, that is Q will be equal to I into T, which is equal to 6 into time in seconds, that is 3600 seconds, and this is equal to 21600 coulombs. Now, number of Faradays of electricity will be equal to charge, that is 21600 coulombs, divided by charge carried by 1 Faraday of electricity, that is 96500 coulombs. Now, equivalents of chromium will be equal to number of Faradays of electricity, which is equal to 21600 divided by 96500. And what is equivalence of chromium? Equivalence of chromium will be equal to weight of chromium, let it be W, divided by equivalent weight of chromium. Now, what is the equivalent weight of chromium? It will be equal to atomic weight of chromium, that is 52, divided by 3. Therefore, equivalence of chromium is equal to 21600 divided by 96500. Now, solving this equation, the value for W is equal to 3.88 gram. Therefore, weight of chromium produced is equal to 3.88 grams. Similarly, the volume of chlorine produced will be equivalents of chlorine. And what is the equivalent of chlorine? Equivalents of chlorine will be equal to volume of chlorine, let it be V, divided by equivalent volume of chlorine, that is 11.2 liters, will be equal to number of Faradays of electricity, that is 21600 divided by 96500. And solving this equation, the value for volume of chlorine will be equal to 2.507 liters. Question 9. A current passes through two cells containing respectively first copper sulfate solution between copper electrode and second silver nitrate solution between platinum electrodes. Calculate the loss or gain in weight of the different electrodes in the time in which 40 cm³ of oxygen at NTP collects in the second cell. Atomic weight of silver is given as 108 and atomic weight of copper is given as 63.5. Now equivalence of oxygen will be equal to equivalence of copper. Volume of oxygen is given as 40 milliliter or volume of oxygen in liters will be 0.04 liters. Now dividing this volume of oxygen by equivalent volume of oxygen, that is 5.6 liters, will give equivalence of oxygen, and this is equal to equivalence of copper. Equivalence of copper will be equal to weight of copper divided by equivalent weight of copper, which is equal to 63.5 divided by 2. Solving this equation, weight of copper is equal to 0.227 gram. Therefore, 0.227 gram of copper gets deposited at the cathode, and the same amount of copper, that is 0.227 gram, dissolves out from the copper anode. This is the first part of the question. Now the second part of the question. In the second part of the question also, the equivalence of oxygen will be equal to equivalence of silver, that is 0.04 divided by 5.6 will be equal to equivalence of silver. Now equivalence of silver will be equal to weight of silver divided by equivalent weight of silver, that is 108. Solving this equation, weight of silver is equal to 0.771 gram. Therefore, 0.771 gram of silver is deposited at the cathode and there is no change in the weight of the anode. Question 10. What weight of water will be decomposed by a current of 100 ampere in 12 hours? Now, equivalence of water, that is weight of water divided by equivalent weight of water, that is 9, will be equal to Faradays of electricity, and Faradays of electricity is equal to charge divided by 96500 coulombs. Now the value of Q is equal to I into T, where I is the current and T is the time. The value of current is given in the question as 100 amperes and value of time is given as 12 hours, which is equal to 12 into 3600 seconds. Putting the value of Q in the above equation, we get weight of water equals to 100 into 12 into 3600 into 9 divided by 96500, which is equal to 403 grams. Question 11. How many grams of hydrogen and oxygen are produced during the electrolysis of water under a 1.30 ampere of current for 5 hours? What volumes of dry gases are produced at NTP? The gases that are produced during electrolysis of water are hydrogen and oxygen. Now, weight of hydrogen produced is equal to electrochemical equivalent of hydrogen into I into T. Now, electrochemical equivalent for hydrogen will be equal to equivalent weight of hydrogen, that is 1 divided by 96500 coulombs. Value for current is given as 1.3 amperes and time is equal to 5 into 3600 seconds. Solving this equation, weight of hydrogen is equal to 0.242 gram. Now to find the volume of hydrogen at NTP, the equivalence of hydrogen will be equal to equivalent volume of hydrogen. The equivalence of hydrogen will be equal to weight of hydrogen, that is 0.242 grams divided by equivalent weight of hydrogen, that is 1, and this is equal to volume of hydrogen, let it be V, divided by equivalent volume of hydrogen, that is 11.2 liters. Solving this, the volume of hydrogen is equal to 2.71 liters. Similarly, the weight of oxygen will be equal to electrochemical equivalent of oxygen, that is Z into I into T. The value for Z will be equal to equivalent weight of oxygen, that is 8 divided by 96500 coulombs. Value of current is given as 1.3 ampere. Time is 5 into 3600 seconds. Solving the equation, the weight of oxygen is equal to 1.94 gram. Now equivalents of oxygen will be equal to equivalent volume of oxygen. Equivalents of oxygen will be equal to weight of oxygen, that is 1.94 gram, divided by equivalent weight of oxygen, that is 8, and this is equal to equivalent volume of oxygen. Now what is equivalent volume of oxygen? The equivalent volume of oxygen is equal to volume of oxygen, let it be VO2, divided by equivalent volume of oxygen. The value for equivalent volume of oxygen is 5.6 liters. Solving this equation, the value for volume of oxygen is equal to 1.36 liters. Question 12. The water is electrolyzed in a cell. Hydrogen is liberated at one electrode and oxygen is simultaneously liberated at the other. In a particular experiment, hydrogen and oxygen so produced were collected together and the total volume measured 16.8 milliliter at NTP. How many coulombs were passed through the cell in the experiment? Equivalents of hydrogen will be equal to equivalents of oxygen, and this will be equal to Faradays of electricity. Faradays of electricity is equal to charge in coulombs divided by charge carried by 1 Faraday, that is 96500 coulombs. Equivalence of hydrogen is equal to volume of hydrogen, let it be VH2, divided by equivalent volume of hydrogen, that is 11.2 liters, and this is equal to Q divided by 96500 coulombs. From this, volume of hydrogen will be equal to Q into 11.2 divided by 96500 liters. Similarly, equivalents of oxygen can be written as volume of oxygen, let it be VO2, divided by equivalent volume of oxygen, that is 5.6 liters, and this is equal to Q divided by 96500 coulombs. From this, volume of oxygen will be equal to Q into 5.6 divided by 96500 liters. Now in the question, the total volume of hydrogen and oxygen is given as 16.8 milliliter or 16.8 divided by 1000 liters. That is, volume of hydrogen plus volume of oxygen is equal to 16.8 divided by 1000 liters, and this is also equal to Q into 11.2 divided by 96500 plus Q into 5.6 divided by 96500. Solving this equation, value of Q is equal to 96.5 coulomb. Question 13. Silver is electrodeposited on a metallic vessel of surface area 800 cm square by passing a current of 0.2 ampere for 3 hours. Calculate the thickness of silver deposited given its density is 10.47 gram per centimeter cube. Now weight of silver deposited is equal to Z into I into T. The value of Z is equal to equivalent weight of silver, that is 108, divided by 96500 coulombs into value of current is given as 0.2 amperes into Time is given as 3 hours, which is also equal to 3 into 3600 seconds. Weight of silver is also equal to volume into density. Volume can be written equal to area, which is given as 800 centimeters square, into thickness of the silver deposited, let it be y centimeter, into density. Density is given as 10.47 gram per centimeter cube. Now from equation 1 and equation 2, we can write 800 into y into 10.47 is equal to 108 divided by 96500 into 0.2 into 3 into 3600. Solving this equation, the value for y is equal to 2.88 into 10 to the power minus 4 centimeter. Question 14. 50 milliliter of hydrogen gas was collected over at 23 degrees centigrade, 740 millimeter mercury barometric pressure. Hydrogen was produced by the electrolysis of water. The voltage was constant at 2.1 volts. The current averaged 0.50 ampere for 12 minutes and 20 seconds. Calculate Avogadro's constant. Time is given as 12 minutes 20 seconds, which is equal to 740 seconds. Avogadro's constant can be denoted by Na. Now charge of 1 mole of electrons is equal to charge on 1 electron, that is 1.6021 into 10 to the power minus 19 into Avogadro's constant, which can be written as Na. Now in this question, to find the number of moles of electrons, first number of moles of hydrogen has to be calculated, and this can be done applying the equation PV is equal to nRT. Value of pressure is equal to 740 by 760 atmosphere. Volume is given as 0.05 liters. Value of R will be 0.0821 and temperature is 300 Kelvin. From this, the number of moles of hydrogen collected is equal to 2 into 10 to the power minus 3 moles. Now 2 moles of H plus ions combine with 2 moles of electrons to form 1 mole of hydrogen gas, or in other words, 1 mole of hydrogen gas will require 2 moles of electron. Therefore, 2 into 10 to the power minus 3 moles of hydrogen will require 2 into 10 to the power minus 3 moles of hydrogen will require 2 into 10 to the power minus 3, which is equal to 4 into 10 to the power minus 3 moles of electron. Now we know the moles of electron. Next step will be to find the charge of 1 mole of electrons. Now total charge involved in this process is equal to Q is equal to I into T. I is given as 0.5 amperes and time is 740 seconds. Therefore Q is equal to 370 coulombs. So charge carried by 4 into 10 to the power minus 3 moles of electrons will be equal to 370 coulombs. From this, charge carried by 1 mole of electrons will be equal to 370 divided by 4 into 10 to the power minus 3 coulombs. And this charge carried by 1 mole of electrons, that is 370 divided by 4 into 10 to the power minus 3 coulombs, is equal to charge carried by 1 electron, that is 1.6021 into 10 to the power minus 19 coulombs into Avogadro's constant. Solving this equation, the Avogadro constant value is equal to 5.8 into 10 to the power 23. Question 15. A current of 0.5 ampere is sent through a solution of copper sulfate for 20 minutes using platinum electrodes. Calculate the weight of copper deposited. Find out the total number of copper atoms deposited. Atomic weight of copper is given as 63.57. Avogadro's constant is equal to 6.022 into 10 to the power 23. 1 Faraday is equal to 96500 coulombs. Weight of copper deposited can be calculated from the formula Z into I into T. The value of Z for copper will be equal to equivalent weight of copper, that is 63.57 divided by 2, where 63.57 is the atomic weight of copper and 2 is the valency factor. This equivalent weight of copper divided by 96500 coulombs will give the value of Z. Value of Z multiplied by value of current, which is given as 0.5 ampere, into time, which is given as 20 minutes, or 20 into 60 seconds. Solving this equation, weight of copper deposited is equal to 0.1976 gram. Now the total number of copper atoms deposited will be equal to the number of copper atoms deposited will be equal to moles of copper. Now moles of copper will be equal to weight of copper, that is 0.1976 gram, divided by atomic weight of copper, that is 63.57. Multiplying this moles of copper with Avogadro's number, that is 6.022 into 10 to the power 23, will give the number of copper atoms, which is equal to 1.87 into 10 to the power 21 atoms. Question 16. What current is required to pass 1 mole of electrons per hour through an electrolytic bath? How many grams of aluminium and cadmium will be liberated by 1 mole of electrons? Charge carried by one electron will be equal to 1.6 into 10 to the power minus 19 coulombs. Now current is equal to charge divided by time. Charge carried by 1 mole of electrons will be 1.6 into 10 to the power minus 19 multiplied by Avogadro's number, because 1 mole of electrons is equal to Avogadro number of electrons. Therefore 1.6 into 10 to the power minus 19 multiplied by Avogadro's number, that is 6.022 into 10 to the power 23, will give the charge carried by 1 mole of electrons. Dividing this by time, time is given as 1 hour, which is equal to 3600 seconds, will give the current, which is equal to 26.8 ampere. Now to find the weight of aluminium and cadmium liberated by 1 mole of electrons, 1 mole of aluminium ions will accept 3 moles of electron and will liberate 1 mole of aluminium. So moles of electron is 3 moles and moles of aluminium liberated is 1 mole. Therefore, 1 mole of electron will liberate 1 by 3 moles of aluminium. Therefore, weight of aluminium will be equal to moles of aluminium, that is 1 by 3, into atomic weight of aluminium, that is 27, and this is equal to 9 grams. Similarly, 1 mole of cadmium ion will accept 2 moles of electron to liberate 1 mole of cadmium. So 2 moles of electron liberates 1 mole of cadmium and 1 mole of electron will liberate 1 by 2 moles of cadmium. Therefore, weight of cadmium will be equal to moles of cadmium, that is 1 by 2, into atomic weight of cadmium, that is 112, and this is equal to 56 gram. Weight of cadmium liberated is 56 gram. Question 17. How many hours are required for a current of 3 ampere to decompose electrolytically 18 gram of water? This is a formula based question. Weight of water is given. Current in amperes is given. Therefore, applying the formula, W is equal to Z into I into T. The weight of water is given as 18 gram. Value for Z is equal to equivalent weight of water, that is 9 divided by 96500 coulombs. Value for current is given as 3 amperes, and we have to find the value for time. Now, putting these values in this equation, we will get the time in seconds. Therefore, to get the time in hours, the value of T will be equal to 18 into 96500 divided by 9 into 3 into 3600. Solving this, the time is equal to 18 hours. Question 18. 50 milliliter of a 0.1 m copper sulfate solution is electrolyzed for 12 minutes at a current of 0.06 ampere. If copper is produced at one electrode and oxygen at the other, what will be the pH of the final solution? For HSO4 dissociating into H plus ion and SO4 2 minus ion, K dissociation or dissociation constant is equal to 1.3 into 10 to the power minus 2. Now the value of K for the reaction H plus SO4 2 minus forming HSO4 minus, the value of K will be equal to 1 by 1.3 into 10 to the power minus 2. Equivalents of copper liberated will be equal to Faradays of electricity, which is again equal to Q divided by 96500 coulombs. Value of Q will be equal to I into T. Value of current is given as 0.06 ampere. Time is given as 12 minutes. Therefore, putting the values, equivalents of copper will be equal to 0.06 into 12 minutes, and multiplying this by 60 will give the time in seconds. Dividing this by 96500 coulombs will give equivalents of copper ions, which is equal to 0.448 into 10 to the power minus 3 equivalents. Now moles of copper will be equal to equivalents of copper, that is 0.448 into 10 to the power minus 3 divided by valency factor, that is 2. 2 is the valency factor of copper. Now this is equal to 0.224 into 10 to the power minus 3 moles. We know the moles of copper and we know the volume of solution is equal to 50 milliliters. Therefore, the concentration of copper ions equal to moles of copper, that is 0.224 into 10 to the power minus 3 divided by volume of solution in liters. The volume of solution is given in milliliters. Therefore, the volume of solution in liters will be 50 into 10 to the power minus 3 liters. And this is equal to 4.48 into 10 to the power minus 3. Therefore, concentration of copper ions discharged is equal to 4.48 into 10 to the power minus 3. Now, equivalents of copper discharged is also equal to equivalents of H plus ions. Therefore, equivalents of H plus ions will also be equal to 0.448 into 10 to the power minus 3. Now, H plus ions are there in the solution because of the reaction that can be written as H2O, 2H2O, which dissociates to give 4H plus ions, plus oxygen gas is evolved, plus 4 electrons. Now, equivalents of H plus ions present in the solution is 0.448 into 10 to the power minus 3. Therefore, moles of H plus ions present in the solution will also be equal to 0.448 into 10 to the power minus 3 because valency factor of H plus is 1. Now the concentration of H plus ions in the solution will be equal to moles of H plus ions, that is 0.448 into 10 to the power minus 3 moles divided by volume of solution in liters, that is 50 into 10 to the power minus 3 liters, and this is equal to 8.96 into 10 to the power minus 3. This is the concentration of H plus ions in the solution. The concentration of sulfate ions in the solution will be equal to 0.1 as it was in the original solution. Now in this equation, where H plus ion combines with SO4 2 minus ion to give HSO4 minus ion, the initial concentration of H plus ions is 8.96 into 10 to the power minus 3. Concentration of sulfate ions is 0.1, and initially the concentration of HSO4 minus ions is 0. Now if X moles of H plus combine with X moles of sulfate ions, then we can write the final concentration of H plus ions will be 8.96 into 10 to the power minus 3 minus X. Final concentration of sulfate ions will be 0.1 minus X, and the concentration of HSO4 minus ions will be X. The value of K for this equation will be 1 by 1.3 into 10 to the power minus 2. Therefore, we can write 1 by 1.3 into 10 to the power minus 2 is equal to X divided by concentration of H plus ions, that is 8.96 into 10 to the power minus 3 minus X into concentration of sulfate ions, that is 0.1 minus X. Solving this equation, the value for X is equal to 0.00788. Subtracting the value of X, the concentration of H plus ion in the solution will be 0.00108. Now pH of solution is equal to minus log H plus ion concentration, which is equal to minus log 0.00108, and solving this, the pH of the solution is equal to 2.96. Question 19. For the electrolytic production of NaClO4 from NaClO3 as per reactions, ClO3 minus ion plus H2O forms ClO4 minus plus 2H plus 2 moles of electron. First, how many faradays of electricity would be required to produce 1 mole of NaClO4? As can be seen from this reaction, 1 mole of ClO3 minus forms 1 mole of ClO4 minus and liberates 2 moles of electrons. Now 1 mole of electron is equal to 1 Faraday of electricity. Therefore, 2 moles of electron will be equal to 2 Faradays of electricity. To produce 1 mole of NaClO4, 2 Faradays of electricity will be required. Second part, what volume of hydrogen at STP would be liberated at the cathode in the time that it takes to form 12.25 gram of NaClO4? Now, equivalence of NaClO4 will be equal to equivalence of hydrogen. Equivalence of NaClO4 will be equal to weight of NaClO4, which is given as 12.25 gram, divided by equivalent weight of NaClO4. Now equivalent weight of NaClO4 will be equal to molecular weight of NaClO4, that is 122.5, divided by valency factor, that is 2. And this is equal to equivalence of hydrogen. Now equivalence of hydrogen will be volume of hydrogen liberated divided by equivalent volume of hydrogen, that is 11.2 liters. Solving this equation, the volume of hydrogen liberated will be equal to 2.24 liters. Question 20. Electric current is passed through two cells A and B in series. Cell A contains an aqueous solution of Ag2SO4 and platinum electrodes. The cell B contains aqueous solution of copper sulfate and copper electrodes. The current is passed till 1.6 gram of oxygen is liberated at the anode of cell A. First, give equations for the reaction taking place at each electrode. Now, in cell A, the reactions taking place are 2H2O gives oxygen gas plus 4H plus ions plus 4 electrons. This is the reaction at the anode. Then Ag plus ions accept electron to form silver, and this is the reaction at the cathode. Now in cell B, copper atoms form Cu2 plus ions plus 2 electrons. This is the reaction at the anode, and copper ions accept 2 electrons and get deposited as copper atoms, and this is the reaction at the cathode. Now second part of the question, calculate the quantities of substances deposited at the cathodes of the two cells. Atomic weight of silver is given as 108 and atomic weight of copper is given as 63.5. Now this was the first part of the question. Now in the second part of the question, now same amount of electric current is passed through both the cells. Now applying the formula, equivalent weight of copper divided by equivalent weight of oxygen is equal to weight of copper deposited divided by weight of oxygen. Now equivalent weight of copper is 63.5 by 2, where 63.5 is the atomic weight of copper, 2 is the valency factor, and equivalent weight of oxygen is 8, and this is equal to weight of copper divided by weight of oxygen. Now weight of oxygen liberated is given as 1.6 gram. Therefore weight of oxygen is 1.6 gram. Solving this equation, weight of copper is equal to 6.35 gram. Similarly, equivalent weight of silver divided by equivalent weight of copper will be equal to weight of silver deposited divided by weight of copper. Now equivalent weight of silver is 108 divided by equivalent weight of copper, which is 63.5 by 2, and this is equal to weight of silver divided by weight of copper, which is 6.35 gram. Solving this equation, weight of silver is equal to 21.6 gram. Question 21. 100 milliliters of 0.8 m copper sulfate is electrolyzed for 30 minutes by passing a current of 5 ampere. Calculate the amount of copper sulfate in grams in the solution. Now in this question, we have to find out the amount of copper sulfate. Now in this question, we have to find out the amount of copper sulfate in grams in the solution. So for this, first we need to find out the weight of copper deposited, which is equal to weight of copper deposited, let it be W, and this will be equal to Z into I into T. Now Z is equal to equivalent weight of copper, that is 63.5 by 2 divided by 96500 coulombs, into I is given as 5 amperes and time is given as 30 minutes or 30 into 60 seconds. Solving this, the weight of copper will be equal to 2.96 grams. Now from the molecular formula of copper sulfate, that is CuSO4, it can be seen that 1 mole of copper combines with 1 mole of sulfate to form 1 mole of copper sulfate. Now initial concentration of copper sulfate in the solution was 0.8 m. Therefore, initially the concentration of copper ions in the solution was 0.8 m. Now from this, initially the weight of copper present in the solution was moles of copper, which will be equal to molarity, that is 0.8, into volume in liters, that is 100 divided by 1000 liters. This gives the moles of copper present initially in the solution, and multiplying this by atomic weight of copper, that is 63.5, will give the weight of copper present initially in the solution, and this is equal to 5.08 grams. Now, out of this 5.08 grams, 2.96 grams is deposited. So, weight of copper in the solution. Weight of copper in the solution will be equal to 5.08 minus 2.96, and this is equal to 2.12 gram. Therefore, moles of copper present in the solution will be equal to weight divided by atomic weight, that is 63.5, and this is equal to weight is 2.12 gram and 63.5 is the atomic weight, and this is equal to 0.0334 moles. Therefore, moles of copper sulfate present in the solution is 0.0334 moles, because moles of copper will be equal to moles of sulfate, which will be equal to moles of copper sulfate. From this, weight of copper sulfate in grams in the solution will be equal to moles of copper sulfate in the solution, that is 0.0334 moles, into molecular weight of copper sulfate, that is 159.5, and this is equal to 5.32 grams. Therefore, weight of copper sulfate in the solution is 5.32 grams. Question 22. Anthracene can be oxidized anodically to anthraquinone. What weight of anthraquinone can be produced by the passage of a current of 1 ampere for 60 minutes if the current efficiency is 100%? The equation can be written as C14H10 plus 3O forming C14H8O2 plus H2O. Now, moles of oxygen taking part in the reaction is 3 moles of oxygen atoms. Now, number of moles into valency factor is equal to number of equivalents. Here, number of moles of oxygen atoms is 3. Valency factor of oxygen is 2. Therefore, number of equivalents of oxygen will be 3 into 2, which is equal to 6 equivalents. Therefore, number of equivalents of oxygen is 6, and 6 equivalents of oxygen will react with 6 equivalents of anthracene to form 6 equivalents of anthraquinone. Now, molecular weight of anthraquinone is 208. Therefore, equivalent weight of anthraquinone will be equal to 208 divided by 6. That is, molecular weight divided by number of equivalents will give the equivalent weight of anthraquinone. Now, applying the formula, W is equal to Z into I into T, where W is the weight of anthraquinone. The value of Z for anthraquinone will be equivalent weight of anthraquinone, that is 208 divided by 6 divided by 96500 coulombs into current is 1 amperes into time is 60 minutes or 60 into 60 seconds. Solving this, the weight of anthraquinone will be equal to 1.2932 gram. Question 23. To reduce nitrobenzene to aniline, 20 gram of nitrobenzene 30 centimeter cube of an alcohol, 250 centimeter cube of water, 11 gram of HCl and 1 gram of SnCl2.2H2O were placed in the cathode space. After passing current at a rate of 26.5 ampere hour through the lead cathode electrolytic cell, 12.76 gram of aniline was produced. Determine the current yield. Now nitrobenzene, that is C6H5NO2, changes to aniline, that is C6H5NH2. The oxidation number of nitrogen in C6H5NO2 is +3 and oxidation number of nitrogen in aniline is -3. Therefore, change in oxidation number is 6. Now moles of nitrogen in 1 mole of nitrobenzene is 1 and moles of nitrogen in 1 mole of aniline is 1. Therefore, change in oxidation number per mole of nitrogen is 6 or valency factor is 6. Therefore, equivalent weight of nitrobenzene, that is C6H5NO2, is equal to molecular weight of nitrobenzene, that is 123, divided by valency factor, that is 6. Now, if the entire 20 gram of nitrobenzene changes to aniline, then equivalents of nitrobenzene will be equal to weight of nitrobenzene, that is 20, divided by equivalent weight of nitrobenzene, that is 123 divided by 6, and this is equal to 0.9756 equivalents. Now equivalents of nitrobenzene will be equal to equivalents of aniline. Therefore, equivalents of aniline, that is C6H5NH2, is equal to 0.9756 equivalents, and from this weight of aniline will be equal to equivalents of aniline, that is 0.9756 equivalents, multiplied by equivalent weight of aniline, which is equal to 93, that is molecular weight of aniline, divided by valency factor of aniline, that is 6. From this, weight of aniline is equal to 15.12 gram. Now this is the weight of aniline which should be produced for 100% current efficiency, but the actual weight of aniline produced is 12.76 gram. Therefore, current yield will be weight of aniline actually produced, that is 12.76 gram, divided by weight of aniline which should be produced if the current efficiency is 100%, that is 15.12 gram, into 100, and this is equal to 84.39%. Therefore, current efficiency is 84.39%. Question 24. 0.2964 gram of copper was deposited on passage of a current of 0.5 ampere for 30 minutes through a solution of copper sulfate. Calculate the atomic weight of copper. Now, weight of copper deposited is equal to Z into I into T. Now, weight of copper is given as 0.2964 grams, and this is equal to Z into I into T. The value of Z will be atomic weight of copper divided by valency factor, that is 2, divided by 96500 coulombs, into current, which is given as 0.5 ampere, into time, which is given as 30 minutes, or 30 into 60 seconds. Solving this, atomic weight of copper is equal to 63.56. Question 25. Most of the copper used to make wire has been electrically refined by depositing it from divalent copper salt solution onto a cathode. What is the cost of electrical energy required per kg of copper if the cost of electricity is rupees 0.25 per kilowatt hour and the cell operates at 0.2 volts. The electrochemical equivalent of copper is 0.00033 gram per coulomb. Now, electrochemical equivalent of copper is given. Weight of copper is given as 1 kg, which is also equal to 1000 gram. So from this, we can find out the value of the charge. Therefore, 0.00033 gram of copper will be deposited by 1 coulomb of electricity, and 1000 gram of copper will be deposited by 1000 divided by 0.00033 coulombs of electricity, which is equal to 30.3 into 10 to the power 5 coulombs of electricity. Now energy is equal to, the electrical energy required will be equal to Q into V. The value of Q is 30.3 into 10 to the power 5 coulombs into V. The value of V is given as 0.2 volts. Therefore 30.3 into 10 to the power 5 into 0.2 is equal to 6.06 into 10 to the power 5 joules. The electrical energy required is 6.06 into 10 to the power 5 joules for 1 kg of copper. Now 3.6 into 10 to the power 6 joules is equal to 1 kilowatt hour. Therefore 6.06 into 10 to the power 5 joules will be equal to 6.06 into 10 to the power 5 divided by 3.6 into 10 to the power 6, and this is equal to 0.168 kilowatt hour. Now the cost of electricity is 0.25 per kilowatt hour. 1 kilowatt hour is equal to rupees 0.25. Therefore 0.168 kilowatt hour will be equal to rupees 0.25 into 0.168, which is equal to rupees 0.042, and this is also equal to 4.2 paise. Question 26. How long should a current of 0.5 ampere be passed through 50 milliliter of a 0.10 m NaCl solution in order to make its pH 12, assuming no volume change? pH is equal to 12, therefore pOH will be equal to 14 minus 12, which is equal to 2. Therefore OH minus ion concentration will be equal to 10 to the power minus 2, or concentration of NaOH will be equal to 10 to the power minus 2. Moles of NaOH will be equal to concentration of NaOH or molarity of NaOH, that is 10 to the power minus 2, into volume of solution in liters, that is 50 into 10 to the power minus 3 liters. From this, weight of NaOH will be equal to, molarity will be equal to moles of NaOH, that is 10 to the power minus 2 into 50 into 10 to the power minus 3 into molecular weight of NaOH, that is 40. Molecular weight of NaOH, that is 40, and this is equal to 2 into 10 to the power minus 2. Applying the formula, W is equal to Z into I into T. The weight of NaOH is 2 into 10 to the power minus 2, and this is equal to Z. The value of Z for NaOH will be equal to equivalent weight of NaOH, that is 40, divided by 96500 coulombs into current, that is 0.5 ampere, into time. Let time be t seconds. Solving this, the value of time will be equal to 96.5 seconds. Question 27. Lake Cayuga has a volume of water estimated to be 8.2 into 10 to the power 12 liters. A power station not so far above Cayuga's waters produces electricity at the rate of 1.5 into 10 to the power 6 coulombs per second at an appropriate voltage. How long would it take to electrolyze the lake? The mass is equal to volume into density. Volume of water is given as 8.2 into 10 to the power 12 liters. Density of water is equal to 1 gram per centimeter cube. Therefore, mass of water will be equal to volume of water in milliliters, that is 8.2 into 10 to the power 12 into 10 to the power 3 milliliters into density of water, that is 1. Solving this, mass of water is equal to 8.2 into 10 to the power 15. Now applying the formula, W is equal to Z into I into T. Weight of water is 8.2 into 10 to the power 15, and this is equal to the value of Z for water will be equivalent weight of water, that is 9 divided by 96500 coulombs into I, the value of current, into I. The value of current is given as 1.5 into 10 to the power 6 into time. Let T be the time. Solving this equation, the value of time is equal to 6 into 10 to the power 13 seconds. Therefore, time in years will be equal to 6 into 10 to the power 13 divided by 3600 into 24 into 365, and solving this, the value of time in years will be 1.9 into 10 to the power 6 years, or 1.9 million years. Question 28. A 200 watt 110 volt incandescent lamp is connected in series with an electrolytic cell of negligible resistance containing a solution of zinc fluoride. What weight of zinc will be deposited from the solution on passing the current for 30 minutes? Atomic weight of zinc is given as 63.5 and 1 Faraday is equal to 96500 coulombs. Value of I will be equal to 200 divided by 110, which is equal to 20 divided by 11. Applying the formula, W is equal to Z into I into T. The value of Z for zinc is equivalent weight of zinc, that is 63.5 divided by 2 divided by 96500 coulombs into I. The value of I is 20 by 11 amperes into T. Time will be equal to 30 minutes or 30 into 60 seconds. Solving this, the weight of zinc deposited is equal to 1.0768 gram. Question 29. 40 milliliter of 0.125 m of nickel sulfate solution is electrolyzed by a current of 0.05 ampere for 40 minutes. First part, write the equation for the reactions occurring at each electrode. The reaction at the cathode will be Ni2 plus ions plus 2 electrons depositing nickel, and reaction at the anode will be H2O, 2 moles of H2O forming oxygen gas plus 4 moles of H plus ions plus 4 moles of electrons. This is the first part of the question. Second part of the question, how many coulombs of electricity passed through the solution? Now coulombs of electricity will be equal to Q is equal to I into T. The value of I is given as 0.05 amperes and time will be 40 minutes or 40 into 60 seconds. Therefore, the coulombs of electricity will be equal to 120 coulombs. The third part of the question, how many grams of the product deposited on the cathode? Now weight of nickel deposited at the cathode will be equal to Z into I into T. The value of Z for nickel will be equivalent weight of nickel, which is 58.7 by 2 divided by 96500 coulombs into I, the value of current is given as 0.05 amperes, into time, which is 40 minutes or 40 into 60 seconds. Solving this, the weight of nickel deposited is equal to 0.037 gram. The fourth part of the question: how long will the same current have to pass through the solution to remove completely the metal ions from the solution? Now, moles of nickel ions present in the solution will be equal to molarity of nickel sulfate solution, that is 0.125 m, into volume of nickel sulfate solution in liters, which will be 40 into 10 to the power minus 3 liters. Therefore, moles of nickel ions will be equal to 5 into 10 to the power minus 3 moles. Now, 1 mole of nickel ions requires 2 moles of electrons. Therefore, 5 into 10 to the power minus 3 moles of nickel ions will require 2 into 5 into 10 to the power minus 3 moles of electrons, which is equal to 10 to the power minus 2 moles of electrons. Now, charge carried by 1 mole of electrons is equal to 1 Faraday, which is also equal to 96500 coulombs. Therefore, charge carried by 10 to the power minus 2 moles of electrons is equal to 10 to the power minus 2 into 96500 coulombs. Now, this charge is also equal to current into time. Therefore, we can write I into T is equal to 10 to the power minus 2 into 96500 coulombs. The value of I is equal to 0.05 amperes. Therefore, time will be equal to 10 to the power minus 2 into 96500 coulombs divided by 0.05, and this is equal to 19,300 seconds. Now, fifth part of the question. Fifth part of the question is, at the end of electrolysis, how many grams of the product would appear at the anode? Weight of product at the anode will be equal to Z into I into T. Now, at anode, oxygen is evolved. Therefore, Z for oxygen will be equal to equivalent weight of oxygen, that is 8, divided by 96500 coulombs into current, which is 0.05 amperes, into time, which is equal to 19300 seconds, because this is the time which is required for the entire process of electrolysis. Therefore, weight of oxygen evolved at the end of electrolysis will be equal to 0.08 gram. Question 30. An electric current is passed through a solution of first silver nitrate, second solution of 10 gram of copper sulfate crystals in 500 milliliter of water. Platinum electrodes being used in each case. After 30 minutes, it was found that 1.307 gram of silver has been deposited. What was the concentration of copper expressed as grams of copper per liter in the copper sulfate solution after electrolysis? Now, same amount of current is passed for the same time through silver nitrate and copper sulfate solution. Therefore, equivalent weight of copper divided by equivalent weight of silver is equal to weight of copper divided by weight of silver. Equivalent weight of copper is 63.5 by 2. Equivalent weight of silver is equal to 108. Weight of silver deposited is given as 1.307 gram. From this, weight of copper will be equal to 0.38 grams. So this is the weight of copper deposited. Now 1 mole of copper sulfate, this hydrated copper sulfate, contains 1 mole of copper atoms. The molar mass of copper sulfate .5H2O is 249.5 gram, and the mass of 1 mole of copper is 63.5 grams. The total amount of copper sulfate present is 10 grams. Now out of 249.5 grams of copper sulfate, 63.5 grams is copper. Therefore, in 10 grams of copper sulfate, the amount of copper present is 2.54 grams. Now out of this 2.54 grams of copper, 0.38 grams of copper is deposited. Therefore, weight of copper left in the solution is equal to weight of copper present initially minus weight of copper deposited after electrolysis, that is 2.54 minus 0.38, and this is equal to 2.16 grams. So this is the weight of copper left in the solution. Therefore, weight of copper left in the solution in grams per liter will be weight of copper left in the solution in grams per liter will be weight of copper, that is 2.16 gram, divided by volume of solution in liters, that is 500 into 10 to the power minus 3 liters, and this is equal to 4.32 grams per liter. Question 31. In a fuel cell, hydrogen and oxygen react to produce electricity. In the process, hydrogen gas is oxidized at the anode and oxygen at the cathode. If 67.2 liters of hydrogen at STP reacts in 15 minutes, what is the average current produced? If the entire current is used for electrodeposition of copper from copper 2 solution, how many grams of copper will be deposited? Equivalence of hydrogen is equal to volume of hydrogen, that is 67.2 liters, divided by equivalent volume of hydrogen, which is equal to 11.2 liters, and this is equal to 6 equivalents. Now equivalence of hydrogen will also be equal to number of Faradays of electricity. Now 1 Faraday of electricity is equal to 96500 coulombs. Therefore 6 Faradays of electricity will be equal to 6 into 96500 coulombs. Therefore current will be equal to Q by T, where Q is equal to 6 into 96500 coulombs divided by time. Time is given as 15 minutes and it is also equal to 15 into 60 seconds. Solving this, the value of current is equal to 643.33 ampere. Now equivalence of hydrogen will also be equal to equivalence of copper. Therefore, weight of copper deposited will be equal to equivalence of copper, that is 6 into equivalent weight of copper, and equivalent weight of copper is 63.5 divided by 2, where 63.5 is the atomic weight of copper and 2 is the valency factor, and this is equal to 190.5 gram. Therefore, weight of copper deposited is 190.5 gram. Question 32. 3 ampere of current was passed through an aqueous solution of an unknown salt of palladium for 1 hour. 2.977 gram of palladium N plus was deposited at the cathode. Find N. Now when palladium N plus ion will deposit at the cathode, it will accept N moles of electrons. Therefore, its valency factor is N. Now weight of palladium deposited is equal to Z into I into T. Now Z is equal to equivalence of palladium, which will be equal to atomic weight of palladium, that is 106.4, divided by valency factor of palladium, that is N, divided by 96500 coulombs, into I is given as 3 amperes, into time. Time is given in hours, into time. Time is given as 1 hour, which is equal to 1 into 3600 seconds. Weight of palladium is given as 2.977 grams. Solving this, the value for N is equal to 4. Question 33. A total of 69,500 coulomb of electricity was required to reduce 37.7 gram of M3 plus to the metal. What is M? Now to change M3 plus ion to metal M, 3 moles of electrons will be accepted by M3 plus ion. 96500 coulomb deposits one equivalent of substance. Therefore, 69500 coulomb will deposit 69500 divided by 96500 equivalents of substance. And this is equal to 695 divided by 965 equivalents. Now, equivalents of metal M is equal to 695 divided by 965, and this is also equal to weight of M3 plus ion, that is 37.7 gram, divided by equivalent weight of this metal M is equal to atomic weight of M divided by its valency factor, which is 3. Solving this equation, atomic weight of M is equal to 157. Question 34. A solution containing copper 1, nickel and zinc cyanide complexes was electrolyzed and deposit of 0.175 gram was obtained. The deposit contained 72.8% copper, 4.3% nickel and 22.9% zinc. No other element was released. Calculate the number of coulombs passed through the solution. A percentage of copper is equal to 72.8%. Therefore, weight of copper is equal to 72.8 by 100 into 0.175, which is equal to 0.1274 grams. From this, equivalents of copper is equal to weight of copper, that is 0.1274 grams, divided by equivalent weight of copper. Now, since the oxidation state of copper in this cyanide complex is +1, therefore its valency factor is equal to 1, and its equivalent weight will be equal to atomic weight, that is 63.5, divided by valency factor, which is 1, and this is equal to 0.002 equivalents. Now, one equivalent of any substance is deposited by 96500 coulombs. Therefore, 0.002 equivalents of copper will be deposited by 0.002 into 96500 coulombs, which is equal to 193.6 coulomb. Similarly, the percentage of nickel present is equal to 4.3%. Therefore, weight of nickel will be equal to 4.3 by 100 into 0.175 gram, and this is equal to 0.0075 gram. From this, equivalent of nickel will be equal to weight of nickel, that is 0.0075 gram, divided by equivalent weight of nickel. Equivalent weight of nickel is atomic weight of nickel, that is 58.7, divided by valency factor of nickel, that is 2. Solving this, equivalence of nickel will be equal to 0.00025 equivalents. Now, one equivalent of any substance is deposited by 96500 coulombs. Therefore, 0.00025 equivalents of nickel will be deposited by 96500 into 0.00025 coulombs, which is equal to 24.66 coulombs. Now percentage of zinc present is 22.9%. Therefore, weight of zinc will be equal to 22.9 divided by 100 into 0.175 grams, and this is equal to 0.04 grams. Now equivalents of zinc will be equal to weight of zinc, that is 0.04 grams, divided by equivalent weight of zinc, that is 65.4 divided by 2, where 65.4 is the atomic weight of zinc and 2 is the valency factor. Solving this, equivalents of zinc is equal to 0.0012 equivalents. One equivalent of any substance is deposited by 96500 coulombs of electricity. Therefore, 0.0012 equivalents of zinc will be deposited by 96500 into 0.0012, and this is equal to 118.04 coulombs. Therefore, the total number of coulombs will be equal to 193.6 coulombs plus 24.66 coulombs plus 118.04 coulombs, and this is equal to 336 coulombs. Question 35. Calculate the minimum number of kilowatt hour of electricity required to produce 1.0 kg of magnesium from electrolysis of molten magnesium chloride if the applied EMF is 5.0 volt. 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. 1 kg of magnesium is equal to 1000 grams of magnesium. Now applying the formula, W is equal to Z into I into T. Now I into T is equal to Q. Therefore, W is equal to Z into Q. The value of W, that is weight of magnesium, is given as 1000 grams. The value of Z for magnesium will be equivalent weight of magnesium, that is 24 divided by 2 divided by 96500 coulombs. Solving this equation, the value of Q will be equal to 8.04 into 10 to the power 6 coulombs. Now energy is equal to charge into V. The value of charge is 8.04 into 10 to the power 6 coulombs, and value of EMF is 5 volts. Therefore, energy is equal to 8.04 into 10 to the power 6 into 5, and this is equal to 4.02 into 10 to the power 6 joules. Now 3.6 into 10 to the power 6 joules is equal to 1 kilowatt hour. Therefore, 4.02 into 10 to the power 6 joules will be equal to number of kilowatt hour is equal to 4.02 into 10 to the power 6 divided by 3.6 into 10 to the power 6, and this is equal to approximately 11 kilowatt hour. Question 36. A sample of Al2O3 dissolved in a molten fluoride bath is electrolyzed using a current of 1.20 ampere. What is the rate of production of aluminium in gram per hour? The oxygen liberated at the positive carbon electrode reacts with the carbon to form carbon dioxide. What mass of carbon dioxide is produced per hour? Now weight of aluminium is equal to Z into I into T. The value of Z for aluminium will be equal to equivalent weight of aluminium, that is 27 by 3 divided by 96500 coulombs into I. The value of current is given as 1.2 ampere into time. Time is given as 1 hour or 3600 seconds. From this, the weight of aluminium is equal to 0.403 gram. Now applying the formula, weight of oxygen divided by equivalent weight of oxygen is equal to weight of aluminium divided by equivalent weight of aluminium. Now equivalent weight of oxygen is equal to 8 grams. Weight of aluminium is equal to 0.403 grams. Equivalent weight of aluminium is equal to 9 grams. Solving this equation, the weight of oxygen is equal to 0.358 grams. Now 32 grams of oxygen reacts with carbon to form 44 grams of carbon dioxide. Therefore, 0.358 grams of oxygen will react with carbon to produce 44 divided by 32 into 0.358, and this is equal to 0.4924 grams of carbon dioxide per hour. 0.358 grams of oxygen is the amount of oxygen produced in 1 hour. Therefore, amount of carbon dioxide produced per hour from 0.358 grams of oxygen will be 0.4924 grams per hour. Question 37. The specific conductance of an n by 10 KCl solution at 18 degrees centigrade is 1.12 into 10 to the power minus 2 per ohm per centimeter. The resistance of the solution contained in the cell is found to be 65 ohms. Calculate the cell constant. Now resistance is equal to 65 ohms. Therefore, conductance will be equal to, that is 1 by R, will be equal to 1 by 65 per ohm. Now, cell constant is equal to specific conductance divided by conductance, and this is equal to, the value of specific conductance is 1.12 into 10 to the power minus 2 per ohm per centimeter, and the value of conductance is equal to 1 by 65 per ohm. Therefore, the value of cell constant will be equal to 0.728 per centimeter. Question 38. When a solution of conductance 1.342 per ohm per meter was placed in a conductivity cell with parallel electrodes, the resistance was found to be 170.5 ohm. The area of the electrodes is 1.86 into 10 to the power minus 4 square meter. Calculate the distance between the two electrodes in meter. Now the unit of conductance given here is per ohm per meter. Therefore, this is the specific conductance. The formula for specific conductance is equal to conductance, which is equal to 1 by R into cell constant. The value for cell constant, the formula for cell constant is equal to L by A, where L is the distance between the electrodes and A is the area. The value for specific conductance is given as 1.342 per ohm per meter. The value for resistance is given as 170.5 ohm. The area of the electrodes is equal to 1.86 into 10 to the power minus 4 square meter. Putting all these values and solving the equation, putting all these values and solving the equation, the value of distance between the two electrodes is equal to, that is the value of L is equal to 4.25 into 10 to the power minus 2 meter. Question 39. The resistance of two electrolytes X and Y were found to be 45 and 100 ohms respectively when equal volumes of both the solutions were taken in the same cell in two different experiments. If equal volumes of these solutions are mixed in the same cell, what will be the conductance of the mixture? Now specific conductance is equal to conductance, that is 1 by R, into cell constant. Now let the specific conductance of the electrolyte X be K1, and this is equal to 1 by 45 into cell constant. Let the cell constant be X. Similarly, the specific conductance of the electrolyte Y, let it be K2, and this will be equal to 1 by 100 into cell constant, which is X. Since the cell is same, therefore cell constant is also same. Now when equal volumes of these solutions are mixed in the same cell, the individual contribution to specific conductance of the mixture will be K1 by 2 and K2 by 2. Therefore, the total specific conductance will be equal to K1 by 2 plus K2 by 2, and this is equal to 1 by R into cell constant, which is X, and this is equal to 1 by 2 K1 plus K2 equals to 1 by R into X. Now putting the values of K1 and K2, we get the equation 1 by 2 X by 45 plus X by 100 is equal to 1 by R into X. Solving this equation, 1 by R, that is conductance of the mixture, is equal to 145 divided by 9000, and this is equal to 0.016 per ohm. Question 40. The resistance of an aqueous solution containing 0.624 gram of copper sulfate 5H2O per 100 centimeter cube of the solution in a conductance cell of cell constant 153.7 per meter is 520 ohms at 298 Kelvin. Calculate the molar conductivity. Molecular weight of CuSO4 5H2O is equal to 249.5. Now molar conductance is equal to specific conductance into volume in centimeter cube containing 1 mole of electrolyte. Now specific conductance is equal to conductance, that is 1 by R, into cell constant, that is L by A. The value of R is given in the question as 520 ohms, and the value of cell constant is equal to 153.7 per meter, or 153.7 into 10 to the power minus 2 per centimeter. Now to find the volume in centimeter cube containing 1 mole of electrolyte, weight of copper sulfate 5H2O is 0.624 gram. Therefore, moles of copper sulfate will be 0.624 grams divided by molecular weight of copper sulfate, that is 249.5. 249.5 is the molecular weight of CuSO4 5H2O. Therefore, 0.624 divided by 249.5 moles of copper sulfate 5H2O is present in 100 centimeter cube of the solution. Therefore, 1 mole of copper sulfate 5H2O is present in 100 into 249.5 divided by 0.624 centimeter cube of solution. Therefore, molar conductance will be equal to 1 by 520 into 153.7 into 10 to the power minus 2 into volume in centimeter cube containing 1 mole of electrolyte, which is equal to 100 into 249.5 divided by 0.624, and solving this, the value of molar conductance is equal to 118.2 per ohm centimeter square. Question 41. An aqueous solution of 0.02 m KCl solution is filled in a 25 cm long capillary tube of internal radius 0.01 cm. The solution was found to have a specific conductance of 0.0027 per ohm per centimeter. What will be the current in ampere when a potential of 2 volts is applied across the capillary tube? Now V is equal to IR. Therefore, I will be equal to V upon R. The value of V is given as 2 volts. Let this be equation 1. The value of R is equal to rho L by A. Rho is the specific resistance. Now specific resistance is equal to 1 by specific conductance. Therefore, putting the value of specific resistance, we get R is equal to 1 by specific conductance into cell constant, that is L by A. The value of specific conductance is given as 0.0027 per ohm per centimeter. The length of capillary tube is equal to 25 centimeter. Area is equal to pi r square, that is 3.14 into the value of radius is 0.01 centimeter. Therefore, r square will be equal to 0.01 whole square. Therefore, value of resistance will be equal to 1 by 0.0027 into 25 divided by 3.14 into 0.01 whole square. Now putting this value of R in equation 1, the value of current will be equal to 6.78 into 10 to the power minus 8 ampere. Question 42. Given the equivalent conductance of sodium butyrate, sodium chloride and hydrogen chloride as 83, 127 and 426 per ohm centimeter square at 25 degrees centigrade respectively. Calculate the equivalent conductance of butyric acid at infinite dilution. Equivalent conductance of butyric acid at infinite dilution, that is lambda C3H7COOH, will be equal to equivalent conductance of sodium butyrate, that is 83 per ohm centimeter square, plus equivalent conductance of hydrogen chloride, that is 426 per ohm centimeter square, minus equivalent conductance of sodium chloride at infinite dilution, that is 127 per ohm centimeter square. and this is equal to 382 per ohm centimeter square. Therefore, equivalent conductance of butyric acid at infinite dilution will be equal to 382 per ohm centimeter square. Question 43. A dilute solution of potassium chloride was placed between two platinum electrodes 10 cm apart, across which a potential of 6 volts was applied. How far would the potassium ion move in 2 hours at 25 degrees centigrade? Ionic conductance of potassium ion at infinite dilution at 25 degrees centigrade is 73.52 per ohm centimeter square. The equivalent ionic conductance is directly proportional to ionic mobility, and this is equal to equivalent ionic conductance is equal to K into ionic mobility. K is the proportionality constant whose value is 96500 coulombs. Ionic mobility is equal to ionic velocity divided by potential gradient. Ionic velocity is in centimeter per second. Potential gradient is equal to potential difference, which is given as 6 volts in this question. So potential difference, that is 6, divided by distance between the electrodes, which is given as 10 centimeter. Equivalent ionic conductance equals to 96500 coulombs into ionic mobility. Let this be equation 1. Now putting the value of ionic mobility in equation 1, the value of equivalent ionic conductance will be equal to 96500 into ionic velocity, let it be V, divided by potential gradient, which is given as 6 by 10. The equivalent ionic conductance of potassium ion at infinite dilution is given in the question as 73.52 per ohm centimeter square. Now from this, the value of ionic velocity, which is equal to distance by time, is equal to 73.52 into 6 by 10 into 1 by 96500. The value of time is given as 2 hours, which is equal to 2 into 3600 seconds. Solving this equation, the distance travelled by potassium ion in 2 hours will be equal to 3.29 centimeter. Question 44. For 0.0128 N solution of acetic acid at 25 degrees centigrade, equivalent conductance of the solution is 1.4 per ohm centimeter square per equivalent, and equivalent conductance at infinite dilution or limiting equivalent conductance is equal to 391 per ohm centimeter square per equivalent. Calculate dissociation constant Ka of acetic acid. The equation for the dissociation of acetic acid is CH3COOH dissociating into CH3COO minus ion and H plus ion. Let the degree of dissociation be alpha. Therefore, if initial concentration is 1, then after dissociation, the equilibrium concentration will be acetic acid will be 1 minus alpha, acetate ion will be alpha, and H plus ion will also be alpha. Now, if the initial concentration is C, then the final concentration becomes C into 1 minus alpha, C alpha, and C alpha. Now, Ka will be equal to concentration of acetate ion into concentration of H plus ion, that is C alpha into C alpha, divided by concentration of acetic acid, that is C1 minus alpha, and this is equal to C alpha square divided by 1 minus alpha. Now if alpha is very small, then this becomes C into alpha square. The value of C is given as 0.0128 and the value of alpha will be equal to equivalent conductance at given dilution divided by limiting equivalent conductance or equivalent conductance at infinite dilution, and this is equal to 1.4 divided by 391. Therefore, value of Ka will be equal to C alpha square, which is equal to 0.0128 into 1.4 divided by 391 whole square. Solving this, the value of dissociation constant will be equal to 1.6 into 10 to the power minus 7. Question 45. The specific conductance at 25 degrees centigrade of a saturated solution of silver chloride in water is 1.826 into 10 to the power minus 6 per ohm per centimeter. If equivalent conductance at infinite dilution or limiting equivalent conductance of AgCl is equal to 138.26 per ohm centimeter square, find out the solubility of AgCl in water in grams per liter. Now when AgCl is dissolved in water, it forms Ag plus and Cl minus ion. Let the solubility of AgCl be x moles per liter. So the concentration of Ag plus ions in solution will be x moles per liter and Cl minus ions will also be x moles per liter. Now the charge on silver ion is 1. Charge on chloride ion is also minus 1. Therefore, number of moles of silver ions or chloride ions is same as the number of equivalents of silver ions and chloride ions. Therefore, the number of equivalents of silver ions or chloride ions in the solution is X equivalents per liter. Therefore, X equivalents of silver ions or chloride ions are present in 1000 milliliter of solution. Therefore, 1 equivalent of silver ion or chloride ion is present in 1000 by X milliliter of solution. Now, equivalent conductance is equal to specific conductance into volume in centimeter cube containing 1 equivalent of electrolyte. The equivalent conductance value is given as 138.26. Specific conductance value is given as 1.826 into 10 to the power minus 6, and this volume is equal to 1000 by X milliliter, where X is the solubility in moles per liter. Solving this, the value of X is equal to 1.32 into 10 to the power minus 5 moles per liter. Therefore, solubility of AgCl in grams per liter, that is solubility of AgCl in grams per liter, will be equal to 1.32 into 10 to the power minus 5 into molecular weight of AgCl, that is 143.5, and this is equal to 1.89 into 10 to the power minus 3 grams per liter. Question 46. Specific conductance of pure water at 25 degrees centigrade is 0.58 into 10 to the power minus 7 per ohm per centimeter. Calculate ionic product of water if ionic conductances of H plus and OH minus ions at infinite dilution are 350 and 198 per ohm centimeter square respectively, at 25 degrees centigrade. Ionic conductance at infinite dilution of H plus ion is equal to 350 per ohm centimeter square. Ionic conductance of OH minus ions at infinite dilution is 198 per ohm centimeter square. Therefore, ionic conductance at infinite dilution for H2O will be ionic conductance of H plus ion plus ionic conductance of OH minus ion at infinite dilution, and this is equal to 548 per ohm centimeter square. Now H2O dissociates to form H plus and OH minus ions. Let the concentration of H plus ions be X moles per liter and OH minus ion be X moles per liter. Now since the charge on both H plus and OH minus ions is 1, therefore number of moles of H plus ions is also equal to number of equivalents of H plus ion, and number of moles of OH minus ion is also equal to number of equivalents of OH minus ions. Therefore, it can also be said that the concentration of H plus ions is X equivalents per liter and concentration of OH minus ions is X equivalents per liter. Therefore, X equivalents are present in 1000 milliliter and one equivalent will be present in 1000 by X milliliter. Now, equivalent conductance at infinite dilution is equal to specific conductance into volume in centimeter cube containing one equivalent of electrolyte. Equivalent conductance at infinite dilution is 548. Specific conductance is given as 0.58 into 10 to the power minus 7, and volume containing one equivalent of the electrolyte is 1000 by X milliliters. From this, the value of X is equal to 1.05 into 10 to the power minus 7 moles per liter, or it can also be said equivalents per liter. Therefore, ionic product of water is equal to product of H plus and OH minus ions present in solution, which is equal to 1.05 into 10 to the power minus 7 whole square, because both H plus and OH minus ion concentration is equal to 1.05 into 10 to the power minus 7 moles per liter, and this is equal to 1.1 into 10 to the power minus 14 moles per liter square. Question 47. The molar conductivity of solution of a weak acid HX, concentration is given as 0.01 m, is 10 times smaller than the molar conductivity of a solution of weak acid HY, whose concentration is given as 0.1 m. If limiting equivalent conductance of X minus ion is equal to limiting equivalent conductance of Y minus, the difference in their pKa values, that is pKa-HX minus pKa-HY is dash. Consider degree of dissociation of both acids to be smaller than 1. Let the concentration of HX be C1 and concentration of HY be C2. Degree of dissociation of HX be alpha 1 and degree of dissociation of HY be alpha 2. Now HX dissociates to form H plus and X minus ions. Now since the initial concentration of HX is C1 and degree of dissociation is alpha 1, the equilibrium concentration can be written as C1 1 minus alpha 1. Concentration of H plus is C1 alpha 1 and concentration of X minus will be C1 alpha 1. Therefore Ka for HX will be equal to C1 alpha 1 into C1 alpha 1 divided by C1 1 minus alpha 1. Now since the value of alpha is smaller than 1, it can be neglected in the denominator and KaHx will be equal to C1 alpha 1 square. Similarly, Hy dissociates to form H plus and Y minus ions, and Ka for Hy will be equal to C2 alpha 2 square. Now according to the question, molar conductivity of Hx divided by molar conductivity of Hy is equal to 1 by 10. Now alpha 1 divided by alpha 2 will be equal to, the value of alpha 1 will be equal to molar conductivity of Hx divided by conductivity at infinite dilution of Hx, and alpha 2 will be equal to conductivity of Hy divided by conductivity at infinite dilution of Hy. Now since the limiting equivalent conductance of X minus and Y minus ions are same, therefore equivalent conductance at infinite dilution of Hx and Hy will also be same. Therefore alpha 1 by alpha 2 will be equal to molar conductivity of Hx divided by molar conductivity of Hy, and this is equal to 1 by 10. Now KaHx divided by KaHy will be equal to C1 alpha 1 square divided by C2 alpha 2 square, or this is also equal to C1 by C2 into alpha 1 by alpha 2 whole square. Now putting the value of C1 and C2 and alpha 1 by alpha 2, the value of C1 by C2 into alpha 1 by alpha 2 whole square will be equal to 0.01 divided by 0.1 into 1 by 10 whole square, and this is equal to 1 by 1000. Therefore KaHx divided by KaHy is equal to C1 by C2 alpha 1 by alpha 2 whole square, and this is equal to 1 by 1000. From this, log KaHx minus log KaHy will be equal to minus 3. Now pKaHx will be equal to minus log KaHx, and pKaHy will be equal to minus log KaHy. Therefore pKaHx minus pKaHy will be equal to 3. Question 48. The conductance of a 0.0015 m aqueous solution of a weak monobasic acid was determined by using a conductivity cell consisting of platinum electrodes. The distance between the electrodes is 120 cm with an area of cross section of 1 cm square. The conductance of this solution was found to be 5 into 10 to the power minus 7 S. The pH of the solution is 4. The value of limiting molar conductivity of this monobasic acid in aqueous solution is Z into 10 to the power 2 S per centimeter per mole. The value of Z is dash. Now let the acid be HA, and this acid dissociates to give H plus and A minus ions. If the initial concentration of the acid is C and degree of dissociation is alpha, then equilibrium concentration will be C1 minus alpha. This is the concentration of HA, and the concentration of H plus and A minus ions will be C alpha and C alpha. Now pH of the solution is given as 4. Therefore, H plus ion concentration in the solution is 10 to the power minus 4. Therefore, C alpha is equal to 10 to the power minus 4. Value of C is given as 0.0015 m. From this, alpha is equal to 10 to the power minus 4 divided by 0.0015. Now the value of specific conductance is equal to rho L by A, where rho is the conductance whose value is given as 5 into 10 to the power minus 7. The value of L, that is the distance between the electrodes, is given as 120 centimeter, and area is equal to 1 centimeter square. The concentration of solution is given as 0.0015 m, which is also equal to 0.0015 moles per liter, and this is also equal to 0.0015 moles per 1000 centimeter cube. Now the value of equivalent molar conductance is equal to specific conductance, that is 5 into 10 to the power minus 7 into 120 by 1 into number of moles present in 1 centimeter cube of solution, which will be equal to 1000 divided by 0.0015. Solving this, the value of equivalent molar conductance is equal to 40 per ohm per centimeter per mole. Now the value of alpha is equal to equivalent molar conductance divided by the limiting molar conductivity. The value of alpha is 10 to the power minus 4 divided by 0.0015. The value of equivalent molar conductance is equal to 40, and from this the value of limiting molar conductivity will be equal to 6 into 10 to the power 2 per ohm per centimeter per mole. Therefore, the value of Z in this question will be equal to, that is the value of Z is equal to 6.